Hello and welcome. This is the third video in the series where we are going to be talking about mole conversions. In the previous two videos, we've talked first about converting grams to moles and moles to grams. The second video, we talked about moles to particles and particles back to moles. This video is where we put it all together and we look at the complete mole roadmap of grams all the way to particles and particles all the way back to grams. Now, in some textbooks, you will see two other branches from moles. One of those dealing with molarity for solutions, and the other one dealing with volume when you're dealing with gases. We are not to that point yet, so we're just going to be looking at grams to particles and particles back to grams, and there will be a later video where we talk about moles to liters and liters back to moles, and how that all ties into this mole roadmap. But for right now, let's move on and talk about the idea of grams all the way to particles. To begin with, as always, we need to look at this idea of mole conversions. Again, just like talked about in the previous two videos, this is just the mathematical process that we're using to go from grams to moles and then to particles, or particles to moles, back to grams. Additionally, don't forget, if we are converting between grams and moles, we need the molar mass of a substance, and that's been covered in a previous video. And if you are going to be converting between moles and particles, we need Avogadro's number. So let's delve a little bit deeper into the complete mole roadmap that we're going to be using. The idea here is that moles are an intermediary, that if we want to go from grams to particles, we first have to calculate the amount of moles. So in converting grams to particles, we end up having to use both conversion factors. The idea of 1 mole per the molar mass to be able to convert grams to moles, and then the second conversion factor of Avogadro's number per 1 mole to be able to convert from moles onto particles. Likewise, if we're going to go from particles all the way back to grams, then we first have to convert particles to moles by using the first conversion factor of 1 mole per Avogadro's number, and then convert those moles onto grams by using the second conversion factor of molar mass per 1 mole. And again, just like I've talked about in the previous two videos, they'll set up the way that they are is so that we can have the canceling out of units between our starting amount and the denominators, so that we're left with the units that are in the numerator and be able to actually convert from one unit to another. So let's go on and start looking at some problems. Okay. So in this first problem, we are looking at converting 50 grams of sodium to particles of sodium. So, excuse me, went the wrong way on the slide there. So when we are looking at this, we are going to, again, as always, diagram the problem. So how many is the question, refers to particles of our substance sodium are in 50 grams, so there's our starting amount of that sodium. So I'm starting at grams and I'm trying to find particles. So looking at this roadmap, I'm going to first need to convert those 50 grams to moles and then convert that number of moles onto particles. And we can do this either in 2 steps or we can do it in 1 step. And I find it to be easier to do it in 1 overall step. So my starting amount, that 50.0 grams of sodium, and then my first conversion factor. I want grams to cancel, and that's why we're dividing by molar mass. But on top, or in my numerator, I'm going to have 1 mole of sodium. And on bottom, in my denominator, I'm going to have the molar mass of sodium, which we find from the periodic table, again, to be 22.99 grams of sodium. After this first step, notice that grams of sodium cancel, and I'd be left with moles of sodium. This is the same thing that we did in the very first video. But I'm not asking for moles of sodium. I want to know the number of particles. So this is where the second step comes in. And again, I could go on and do the math, 50 divided by 22.99, and find that number of moles, and then start a second problem of moles to particles and follow the process that we did in the second video. But to me, it's much easier to string it together and just do it all at once in the calculator. So now, in my second step, I want moles to cancel. So that means in the denominator of my second step, I need moles. And notice in that mole roadmap, that's what it has us do. And on top in my numerator, I'm going to have Avogadro's number of particles of Na. And again, this question could read how many atoms of sodium, but we're going to use that generic catch-all term of particles. So after my second step, notice the numerator of moles sodium from the first step cancel the denominator of moles sodium in the second step, and the only units I'm going to have remaining are particles of sodium, which is what the question is asking for. And now I can do the math. I'm going to again multiply by my numerator, divide by denominator in each step, and you can either do all the multiplying and then all the dividing, or you can do it step by step. I typically go step by step. So I'm going to type in 50.0 times 1 divided by 22.99 and then multiply by, and again, because I've got a number that's in scientific notation, I'm either going to put that into parentheses or use that E button, and I prefer the E button. So after 50.0 divided by 22.99 times 6.02, second comma, to get that E, and then 23, hit enter, and I get a final answer of 1.309, but to 3 significant digit, that's going to be 1.31, and then at the tail end, don't forget the E24 in your calculator. Also remember that it's perfectly fine to write this as 1.31 times 10 to the 24th, and then particles of sodium. So either format is valid. So that's the first problem. So let's go on and work a second. So this problem is asking us to how many particles of HCl are in 35 grams of HCl. So how many particles of a substance are in a starting amount given in grams of that substance. And like always, if you want to pause the video, give this one an attempt, and then unpause it and check your work using my work, please feel free to do so. So working this, my starting amount is grams. I'm going to particles. So 35.0 grams of HCl. My first step is going to be to convert those grams to moles. So I'm going to need 1 mole of HCl per its molar mass. And if you recall from a previous video, hydrogen is a mass of 1.01, chlorine is a mass of 35.45, and when we added those up, we got a molar mass of 36.46 grams of HCl. After this first step, grams HCl would cancel. And again, I could go on and work this and find my moles of HCl and then do the second step. I prefer to string it all together. So my second step, I would take and convert moles onto particles. And for that, I would need Avogadro's number of particles of HCl, which we could also refer to as formula units, per 1 mole of HCl. And again, verify that numerator cancels the denominator. And the only units I'm going to have remaining are those of particles, HCl, and then do the math. Multiply by your numerators, divide by your denominators. So in my calculator, I'm going to type in 35.0 divided by 36.46 times 6.02, second comma to get the E, and then 23, and hit enter. And I get an answer of 5.778 times 10 to the 23rd. So to 3 significant digits, 5.78, and then the E23 particles of HCl. Again, you could just as easily write this as 5.78 times 10 to the 23rd. Please don't forget to look to the tail end, the far right-hand side of that value in the calculator, to see if there is an exponent. You don't want to leave that off, because there is a vast difference between 5.78 and 5.78 times 10 to the 23rd. So please make sure that you're checking your calculator to see if there's an exponent. So those two problems are where we're converting from grams to particles. Now let's take a look at a problem where we are trying to find how many grams starting with particles. So in this one, how many grams is our question in HCl if I'm starting with 2.5 times 10 to the 24th particles. So my starting amount is in particles. Grams are my question. So I'm going to take my starting amount, 2.50 times 10 to the 24th particles of HCl. And you might recall this question from the previous video where all we did was convert particles to moles. So I'm going to repeat that first step. And because I'm going particles to moles, I need the bottom portion of that roadmap, where it will be set up as 1 mole of HCl per 6.02 times 10 to the 23rd particles of HCl. And again, after that first step, those units of particles, HCl, will cancel and leave us with moles. But because I'm asking for grams, I've got to do this second step. And I string it together. So my second step, I need the molar mass of HCl, which again is 36.46 grams of HCl for every 1 mole of HCl. Again, notice my numerator in the first step cancels the denominator in the second step, and the only units remaining are those of grams HCl, and then I would do the math. Multiply by the numerators, divide by the denominators. So in doing so, in my calculator, again, you're either going to want to put these values that are written in scientific notation inside of parentheses or use the E button. So 2.50 E24 divided by 6.02 E23 multiply by 36.46, and I don't worry about the multiplying or dividing by 1, and then hit enter, and I get an answer of 151.4, or to just 3 significant digits, 151 grams of HCl. So last problem. This 5.30 times 10 to the 23rd particles of Na to grams of Na. So I am converting, again, how many is the question of my substance are in a starting amount of particles. So I'm going to take this starting amount of 5.30 times 10 to the 23rd. Grams are what I'm trying to find. Particles are my starting amount. You'll notice that in this video, I've corrected that starting amount so it matches the upper portion. But what I'm going to do again is convert those particles to moles first. So I need 1 mole of sodium over Avogadro's number of particles of sodium. And in doing so, notice that particles sodium will cancel. And then my second step of converting moles to grams, I'm going to need the molar mass of sodium, which on the periodic table is 22.99 grams of sodium. And that's going to be per 1 mole of sodium. And again, numerator, the first step, those units cancel the units in the denominator of the second step. Then I would do the math. Again, always multiply by your numerator, divide by your denominator, and also either use parentheses around these values that are in scientific notation or use the exponent key. So I'm going to now type this into my calculator. 5.30 E23 divide by 6.02 E23 multiply by 22.99, because again, I don't worry about the multiplying or dividing by 1. And I get a final answer of 20.24, or to 3 significant digits, 20.2. And after the canceling of units, the only units I have remaining are those grams of sodium. So hopefully everything made sense. If not, feel free to leave a question in the comment section. I'll be sure to get back to you as soon as possible. Also, don't forget to subscribe to this channel so you don't miss out when I upload new content. Additionally, if you have any suggestions for future videos, please let me know and I'll do my best to get them made. Hopefully all of this made sense, and appreciate you. Take care.